Hello everybody and welcome back to the multiplayer project where I'm pretty sure we're ready to go. Um, this gets a little hacky, just throwing that out there. Like, our latency calculation on the server side works wonderfully. On the client side, less so. And I think I know why, but we'll go over that a little bit later. You may notice we're not just doing latency compensation here, we're doing input rate limiting and latency compensation. So first things first, let's hop into our client, which we're already in here, and let's go into our managers here. I want to do one quick thing here, and this is not necessary and is certainly something that we're going to change a little bit later on, but I just don't want the game running at 1200 FPS right now. It's a complete waste of energy, so we're just going to do application target frame rate equals 120. And that'll just cap it down. It won't actually run at 120, but it'll run at sub 200 now. So that's good. Now, we're going to need to do a little bit in the net manager with our latency calculations here. First thing that we'd like to do is we'd like to go down to our update function here and leave this almost exactly the same, but I want this to be, instead of delta time, unscaled delta time. So in case we do anything with timescales, that won't mess anything up. Excellent. And then we need to go down to where we're actually handling our time here. So currently our latency is taken by calculating our server time minus updated time and taking the total milliseconds. That's all well and good, but this number is frequently negative, and we don't have a negative latency. I can tell you that right now. So we're just going to do mathf.abs. We're going to take the absolute value of that. There we go. And if I can not hit the underscore, that would be great. Wonderful. And so that gives us the absolute value of this so that we are always positive. So that's useful. We could take updated time minus server time because for some reason that is... Well, that is... Updated time is going to be ahead, right? Because we know for a fact that server time is our last received timestamp, and then we go from there. So our latency is always going to be that. So we'll do updated time minus server time. And that will always be positive, and so the absolute value call isn't necessarily necessary, but we know that this is always going to be a positive number, so we'll just take the absolute value, because if it's a negative number, then we've got some issues. Now this is a round trip time here, kind of. Actually, it's not, now that I think about it. This is not a round trip time, because this is just response from the server. Okay, so we're not going to divide this by 2. We are, however, going to subtract 100 milliseconds from it. For whatever reason, it's always 100 milliseconds off. And I'm not entirely sure why that is, but my theory is because it has to do with when the update versus the game tick time happens. And so this adjusts it so that the client's latency is in line with the server's. In theory. Or approximately in line with the servers. We can put this into our to-dos here, so we can change our latency calculation here to may not work in real-world scenarios. So when we're testing this in a more real-world scenario, we'll just check to see if that works. Excellent. So let's go back into our net manager here, and there is one more thing that we want to do over here, I believe. Why is this marked as something that I edited? I'm fairly certain I didn't edit this. Let's see. Respond with our own public key? Yeah, I did not edit this. I don't know why that's... Oh, I did edit this. Of course I did. Because we now need to change how we're doing our timestamps. Because currently we're just sending all of these over to our UDP class. So if we go to UDP here, we're taking datetime.now. Now that grabs our system time, which, I mean, we can change this. We don't necessarily want that. We want to be working entirely off of server time. So for each of these, we're going to add in a date time server time. Excellent. And we're just going to copy that in here, as well as here. And instead of datetime.now.toString, we're just going to do servertime.toString for each of these timestamps. Excellent. So this means that our clients are always going to be running sometime in the past from where our server is. But that's okay. This is kind of what we expect with our latency compensation. So that is going to create ourselves some issues in the net manager, of course. So we'll just toss in a server time here, and I'll copy this again with the comma so that I can just paste it in. We now know that server time is always the final parameter for every send. And we'll just work those into the net manager's wrapper around send. Still need two more. So we need one here, as well as one here. Excellent. Okay, so there we go. We got that changed around. The server is going to be receiving exactly the same thing from its perspective, so nothing needs to change there. But now we're using just server time, and there is no client time being used whatsoever. So that's excellent. Now we're going to need to do some work in the input manager because we need to do this input rate limiting. Now we're going to do this kind of in a silly sort of way almost. Like, it's not going to be automated. The main thing that I was concerned about is when we were just clicking and dragging with input.getMouseButton1, we were sending, our frame rate was around 1200. We were sending around 1200 messages per second, and I don't want to spam that. But some things we should send high priority, and some things are a low priority. So let's do a region rate limiting. And we'll just go ahead and end that region. And inside of this, we'll have two things. Public const int rate limit equals 100. And that'll be in milliseconds. And then private int rate equals 0. Okay, there we go. Now, let's do a couple more things here. We're actually going to need another region here. So we'll do a region properties. We'll end that region. And I guess we might as well make this be a region references. And we'll end that region as well. And we'll minimize this region for now, as well as this one. We're actually done with that for now. And in the properties, we're just going to do public int. This will be delta ms. And we'll just do a private set. Excellent. And we'll also do a get. And when we get this, we're going to do return mathf.roundToInt time.unscaled delta time times 1000f. So that just gets us our unscaled delta time in milliseconds rounded to the nearest integer. In fact, we could floor to int, but I think we'll just round to int for right now. I suppose, can we make properties read-only? No. Okay. Just wanted to double check that. Excellent. So we're going to have to change around our update a fair amount. Let's go ahead and take everything inside of here and move that into its own method at this point, because we have multiple things that might want to do that to find mouse position. So we'll do public, or rather, we'll do private void find mouse position bool send equals true. Excellent. And then we'll just paste that in right here. And then we're going to modify this down here a little bit. So if send, then we will do this. Excellent. And then we're also going to do a private void q command. And this will be bool high priority equals false. But we'll do that at the end because we want to pass in command types command type, and also params. I didn't think this through. Params string parameters. Can we do that without it being the final? No, it has to be the last priority. So I guess we'll have to make this not be default. Actually, let me redo that. There we go. We'll have to do bool high priority, and we can't have a default for that. Okay, that's fine. Oops. There we go. Okay, so we will now do something along the lines of if high priority, then we will just have it simply do managers.netmanager.send command. It'll just instantly send it. Command.toUDP message. And then it'll be command types.move and hitPoint.toString. Of course, we aren't passing that in. This would just be parameters. I was copying from this when I needed to copy from my other project. Okay, so this here will replace this line with, instead, Q command. And this will be send. So we actually don't need to do this inside of this if statement, now that I think about it. So we'll do Q command send command types.move, and this will be hitPoint.toString. Excellent. So that gets us our command queued up, in theory. But, in reality, this is only if this send is true. And let's actually rename this to high priority. Okay. And we should go ahead and call find mouse position here, except that this is a low priority call. Reason being, we are dragging this, so we only want to do that at a certain time. Let's go ahead and create ourselves a private list string command Q equals new list string. Excellent. So otherwise, if it's not high priority, then we will say command Q dot add, and that would be command dot toUDP message, and this would be command type and parameters. And of course, here we should just pass in command type rather than command type.move. Wonderful. So if it's high priority, then it will send it immediately. Otherwise, if it's low priority, we'll add it to the queue. Excellent. And then we will also go ahead and do some more work in the update here. So if rate is greater than 0, then we can say rate minus equals delta ms. So if our rate is above 0, then we'll subtract out delta ms, and then we'll do some calculation here. First thing I want to do is I want to add support for sending a high priority when we click, and then a low priority as we're dragging. So we'll do if input dot get mouse button down 1. So when we actually click, then it'll do that. And then we'll do an else if input dot get mouse button 1. So it'll only do one of these, and it'll prioritize the actual click event. So then we want to do find mouse position true, or we could just leave this empty because it defaults to true. So this is a high priority event here. So we want to always immediately process a click. But then we want to say, but delay any held events for rate limit milliseconds. Because we want to say at this point, rate equals rate limit. Excellent. So we'll always immediately process the click event, but if we're going to drag, we only want to process one drag event every 100 milliseconds. Or rather, we only want to send it. We want to process it all the time. So inside of here, let's check if rate is less than or equal to 0. Rate limit the updates when we're holding to once every rate limit ms. So if this is true, then of course we want to find mouse position false. Or rather, yeah, we want to find mouse position false here. And we want to say, hang on, find mouse position false. There we go. And we want to say rate equals rate limit, because we're resetting that. Wonderful. Otherwise, we want to say find mouse position false. Okay, and we actually want this to be, we want this one to be like this. And the high priority, I'm actually going to rename this back because it's not working how I thought it was going to work. So this, instead of being high priority, this will be send. We want it to process this every time, but we only want it to queue command if send. So back to the way it was before I decided to change it. And then we can just say true here, because at this point, this is not high priority. So this would be false. If we send it, then we queue that up, but falsely. Excellent. So we queue it as a low priority, so it gets added to the queue rather than being sent immediately. Now, over here, if rate is less than 0, then we should do rate equals 0. But we should also go ahead and process the queue. But we're only adding to the queue, like we're limiting our adds to the queue, right? So we want to process the queue every frame. So we'll do process queue. And then we'll do a private void process queue. And what this is going to do is this is just going to if command q dot count is greater than 0, then we are simply going to say managers.netmanager.send command, and we want to pass in command q 0. Then we also want to set our rate. Actually, we don't want to set our rate limit here because we're limiting the speed at which we add things rather than the speed at which we pull them out. And the reason that we're doing that is because our frame rate is potentially going to just spam a ton of things into the queue here. And we don't want it to process one of those every 100 milliseconds. We'd rather sample this once every 100 milliseconds. Or however many we decide the rate limit should be. Excellent. So that's our input manager done there. And that's our rate limiting overall done. And we're now also using server time rather than local time, which is going to be very useful. So let's hop over to the server and work on a little bit of latency compensation. Now this is going to be a relatively simple, almost simplistic implementation here. Let me just see. Yeah, we didn't change anything in Game Manager. I just had that open for no real reason. Okay, so in server here, we can go ahead and change a couple of things. The only things that we really changed was in line 272, right around here. Because we need to add another line here, and this is client session.instance.insert move command into past, which of course doesn't exist. We're going to do a little time travel here to compensate for this. So client session.entity, and we're also going to pass in client session.last message, which is actually our timestamp of the last time we received a message here, which got automatically updated already. So of course that doesn't exist. So let's hop into instance here, and we will implement that. So I'll put this, I think, right above tick. And we'll put this at public void insert into, or rather insert movement command into past. And we'll do entity, entity, and date, time, timestamp. Excellent. So we'll calculate our latency here, and we'll calculate that with float latency equals mathf.abs. So we take the absolute value of the current time, date time dot now, and we don't care about using system time for the server because we control the server. Then we say minus timestamp dot total milliseconds, and we don't actually care about round trip time here, so we're not going to divide that by 2. So this is absolutely fine. That gives us our latency, and this should be in the most of the time anyway, in the single digits, at least when we're on localhost like this. Okay, so we could debug out our latency here, and I have that in my other project, but we're not going to do that here because I know that this outputs reasonable numbers. So we're then going to say int ticks equals int mathf, which is a capital F in C# rather than Unity, dot floor. So we're going to floor the latency divided by game manager dot, what am I doing? Game manager in lowercase. Wow, I cannot type. We already knew that though. Dot game speed. So that gets us our number of ticks that have gone by since the client issued the command. So we now know that, so we'll just say for int I equals 0, I is less than ticks, I plus plus, entity dot on tick. So if we are more than 1 tick away, then, or 1 or more tick away in terms of our latency, then it will immediately jump forward towards the destination position by that many ticks. So that way, the client should no longer start moving immediately, then snap back a little bit, and then start moving properly, because the client was expecting some level of latency compensation. And that's what we were seeing, was some level of latency compensation. Okay, I think that's everything on that front. Now, I believe I made a couple of changes in here, but we do want to have our net manager open here so that we can see our latency. Let's go ahead and fire up our server here and do a couple of tests. Build errors. Name client session does not exist. Hang on. Insert move command into past. What did I call this? Movement command into past. That would do it. Any other errors? Client session does not exist. I'm sorry, what? I'm sorry, what? What do you mean client session doesn't exist? Like, did I typo it? Oh, I did. There's 3 S's. Okay, well that explains a lot. Let's try this again. Okay, we'll fire this guy up. I don't know why it's flashing white all of a sudden. It wasn't doing that previously. I think it has to do with the lighting generation. I don't know. We'll go ahead and log in, and we'll enter this world. Our camera starts pretty zoomed in, and I want to change that. I also want to change the strength of this, but we'll just go ahead and boom. Oh, yeah. Whoa. Hmm. Something is broken. I clearly did something wrong. What did I do wrong here? It sends in... Okay. It seems to be on server side that I did it wrong. Let's see here. Entity.desired position equals this vector 3. Yes, that is correct. Insert move command into past. It must be something in insert move command into past that I forgot to do. No. Okay, maybe it is in the command issuance. It might have to do with the queue, because... it should process that every frame that it gets added in. That should work exactly the same way that I coded it previously. Which was just that it didn't send. Like, there was no queue. It just didn't send it. So I guess... we'll change it over to not have the queue, because it's not strictly speaking necessary. So in that case, all we would need to do is get rid of the high priority check and everything else, and it would just be a wrapper for this line. So we'll do that. And then we'll do that. We'll get rid of the queue and see if this fixes it. It shouldn't. Like, this should be literally the same thing. I would think. You know what? I wasn't calling false here. Except that send. Right. Yeah, that would cause an issue. Okay, we're just going back to how I had it previously, so we're just removing all references to the queue, and otherwise just leaving it exactly like this. And now it should work absolutely fine, in theory. Why did I fire up the client first? This is never going to work. There we go. We're going to fire up the server now. And now the client. And then we'll log in. I think I typoed that password. Let me try that again. There we go. Encryption handshake complete. Okay, so we move there. We move here. We can drag it around. And you can see it jerks a little bit when we're changing directions. That's because the latency compensation and the interpolation don't communicate instantly, and there's not much that we can do about that. The server does... Why did after a little while it snapped our direction this way? We'll see if it happens again. It did. You know why? I know why. It's because we are sending the rotation every 100 messages. So every little while, it receives a full update from the server and snaps it back. Yeah, that's why. We'll add that to our list of known bugs. Okay. So as I was saying, there is not much that we can do about that little bit of jerk as we're changing directions because of the latency compensation and interpolation not communicating quite instantly. So they're just kind of doing their own thing, and then we're coming at it on the server. We're coming at the new position from a slightly different direction, and that's why we have that tiny little bit of a jerk. But I think that's ultimately okay. So for right now, let's add in this known issue here, where every time we receive a full update from the server, it resets our interpolated facing direction. Okay. There we go. So that's a known issue, and we can come back to that a little bit later on, but we have a fair amount of time left in this one. I knew this would be a relatively short one because this went a little bit faster than I was anticipating. In the meantime, let's work real quick on our zoom speed here. Are we using scroll speed for some reason? Because it does not feel like it's 100. Let's go into, this is our server. Let's just go into here and edit this script. Times scroll speed. That would help. Okay. So our zoom level, let's have this default, instead of being at -5, let's have this default to, say, -15. Which I believe is what our actual position is at. Yes. Okay, so that should cause our zooming to work much better. And now we can unlock our camera here. And we can work a little bit on some scrolling. So, that's fine, Visual Studio. You can go away with that update for right now. So, if we're not locked, or we don't have a player entity, then we should, at this point, allow our camera to scroll. So let's do a public int scroll threshold equals, we'll say 5f. Does not need to be a floating point number. There we go. Scroll threshold equals 5. And then we'll say input, or we'll actually do something like a vector2 mouse pose equals input dot mouse position, which I believe that outputs a vector 3, but I believe it's just using an x and a y. So that should work fine. And now we will say something along the lines of if mousepose.x is less than scroll threshold, then we want to pan the camera left. Else, actually we don't want to do else's, because we want to be able to scroll diagonally as well. So if mousepose.x is greater than screen.width minus scroll threshold. By the way, this is live at this point. I'm not prepared for this. I've implemented this sort of thing before, though. So at this point, we want to pan the camera right. And then we want to do the same thing on the y-axis. And actually, this can be else if. And then this down here would be a separate if statement. If mousepose.y is less than scroll threshold, then we want to, at this point, I believe it's pan the camera down. Else, if mousepose.y is greater than screen.height minus scroll threshold, then we want to, I believe this is pan the camera up. And we can also bind these to hotkeys as well. In the input manager, we'd probably want a reference to a hotkeys object wherein we store all of this information. And actually, let's go ahead and make that. So let's go to input here, and we will do a public C# script keybinds. And let's also go ahead and make another one, C# script keybind singular. So we've got our keybinds and our keybind. And in the input manager, let's just go ahead and assign the keybind script. Keybinds here is not going to be a mono behavior. Or rather, keybind singular is not going to be a mono behavior. Keybinds should be a mono behavior. Did I set this correctly? I did not. We want keybinds to be here, and we want to remove the keybind component. This should not be a mono behavior. Okay. Wonderful. We do want this to be system.serializable. Wonderful. And we want to do something like this. Region keys and region. And then we'll do region. We'll call this methods and region. That's really generic, calling it methods. We'll just do check methods. Okay. So we'll do a public key code primary secondary. Excellent. So this is going to allow us to bind two things to the same. We could do more if we wanted. We could have tertiary, quaternary, on and on and on. But we're not going to do that for right now. We're just going to support primary and secondary. We could support mouse bindings as well. Public bool mouse bindings. And we could do this on both the primary and secondary level. So mouse binding secondary, because we have to check key bindings and mouse bindings separately, right? And we could also do theoretically axis bindings. But we'll then do a public int mouse primary and mouse secondary. And we'll go ahead and call this key primary and key secondary. For right now, we're not going to support any gamepads or joysticks or anything, but this is an area where we could do that. So in the to-dos, we'll do support gamepads in keybinds. We'll just add that in there, and for right now, that's all we're going to do. We do not need a start or an update for keybinds. This is mostly just a data class. So we've got our key primary, key secondary, mouse secondary, and a boolean for determining which we are doing. So we're going to want a couple of methods, public bool pressed. We're going to need public bool held. And we're going to need public bool released. This should be pretty obvious. Get rid of that. And we'll say returns true on the frame the keybind is pressed. And I forgot a Y. There you go. Otherwise, false. And we'll just copy this, and we'll put this in here and here. And this would be on the frame the keybind is held. And this would be released. Okay. So, these are going to be slightly complicated by the fact that we're supporting mouse bindings as well for mouse buttons. So, we'll just go ahead and say if mouse binding primary, and then this would be return, or actually, we only want to return this if it's true, and we're going to have to do this with several different things. So if the mouse binding is on the primary, we want to say if input dot get mouse button down, and this would be mouse primary, then we want to return true. And then we'll say at the end, return false. Okay, so that's if our mouse binding is for the primary button. And then we want to say if, we don't want to else if this, if mouse binding secondary, then we'll say if input.get mouse button down, this would be the mouse secondary, return true. And then here is where we'll do else's. So if our mouse binding is our primary binding here, that's all well and good. But if it's not, for now anyway, we can assume that this is a key binding. So if input.get key down, and then this would be key primary, return true. And then we're going to do the same thing here. We're just going to copy that in, and this will be key secondary. And if none of that is true, then it will return false. Wonderful. We're going to copy this whole thing and put it into held. And instead of get button down, it's just get button and get key. There we go. So that'll return on frames in which these buttons are held. And we'll do the same thing here. Instead of up, it will be, or instead of down, it will be up. So get key down, get key up, get mouse button up, and get key up. Wonderful. So with all of those in, that gives us our keybind. So now we can set up some keybinds. Public keybind, and this is going to be camera pan left, camera pan right, camera pan up, and camera pan down. Wonderful. So that gives us our 4 keybinds there. And if we hop into our inspector here and take a look at the input manager, we'll see our keybinds. And here we go. We can set up whether our mouse bindings are set up for the primary or the secondary. We can set up a primary and secondary key for all of these. Excellent. Now, we're not actually going to check those there, per se. This is the server. We need to be in the client right now. So what we're going to do here is we're just going to hop over to our camera script, and we do have access to the managers. So we need to say if our mouse position is in position to pan, or we can say managers.inputmanager.keybinds, which doesn't exist yet. And actually, let's go ahead and set that up. Input manager, and then we'll have in our references public keybinds, and we'll set that up in the inspector as well before I inevitably forget to. We'll just put that right there. Fancy. And I'd kind of like that to be above the player entity. Oh, hello, desktop. I'd kind of like that to be above the player entity, so let's just place it up there, and we'll see if it moves it or if we have to reposition it. It moved it. Wonderful. Okay. So now we can come down here, and of course, in our ARPG camera, we've got a compiler error. .keybinds .camera pan left .held. Technically, we could make those be properties, but I think it's fine being methods. So yeah, camera pan left .held, and then we'll copy this here and paste it here and here and here. And this should be camera pan right .held. This should be camera pan down .held, I believe. And this should be camera pan up .held. Wonderful. And now we will say something along the lines of vector 3 camera direction equals vector 3.0. Wonderful. And now when we want to pan left, we'll just say camera direction plus equals, let's see here, this should be a negative x. But we can just, I believe, say vector 3 dot left. Hopefully these are the correct directions. Vector 3 dot right. And then we will add in vector 3 dot down. Except we don't want this to be on the y-axis. Want this to be on the z-axis. Is there a vector 3 dot... Yeah, this would be a vector 3 dot back. And then this would be a vector 3 dot forward. Excellent. Then down here, we're going to say camera direction equals camera direction dot normalized. And then we will, of course, say something along the lines of transform dot position plus equals camera direction times scroll speed, which is probably going to be really slow to start with, times time dot delta time. Okay, so that should allow us to scroll the camera, in theory. I'm not sure about these directions. We may have to change these, but we'll see. The camera target does have a rotation of 50, so that may change things. We'll see. Let's go ahead and fire up our server, and we'll see if we can do this. Our camera is currently not locked. We have a compiler error. Oh yeah, I typoed transform. Of course I did. There we go. Okay, we'll fire this up. Oh, I was too impatient. This isn't going to work. Go ahead and shut down the server. Yep, server connection interrupted. That is to be expected. We'll bring the server back up. Yep, that's fine, Visual Studio. You can go away. And we'll do ASDF, ASDF, and this time I'm going to wait until we have our encryption handshake complete. Which may be altogether too long. And it was, but there we go. Okay, so we are now logged in, and you can see, whoa, that's kind of jumping a lot more than it was. Interesting. We'll look into that in a moment. And looks like our scrolling works correctly. It's just slow. And of course, we haven't set up keybinds for it yet, but those should work fine. So let's do that quickly. So for pan left, we will set our primary keybind to be A. Not back quote. We will have it be A. There we go. And the secondary will be the up arrow, which I passed. There we go. And then for right, it will of course be D. And then that would be the right arrow. For up, it would be W, as well as up arrow. And for down, it would be S and down arrow. So that should be our camera controls done there. We can make regions for those and headers, and that's all well and good. We can organize the keybinds and get those set up with the options menu in a little while. But that's not the focus that we're on right now. And I'm just wondering why exactly that was jumping so much. Was I just not noticing it when the camera was locked? We're going to go ahead and lock the camera for right now and see if that fixes it, or quote unquote fixes it. Yeah, of course, we don't have the server up. Or if this is just an issue that has cropped up at some point that I need to try to sort out before the end of this episode. So we'll see here in a moment. Okay, go ahead and log in. Nope. That's an issue that's cropped up. Okay. Because that level of jerking was not present. Well, let's test the camera quickly. We'll unlock that. I'm also going to bump the scroll speed up to 10. That's much better on the scroll speed. It's still a little slow. WASDA works. That's interesting. The up arrow is sending us diagonal, and the left arrow doesn't work at all, despite the fact that WASDA works fine. So it's clearly a problem with the keybinds here. Up is set to up arrow, and left is also set to up arrow. That explains it. This needs to be set to left arrow. Okay, so keybinds work fine, and the camera controls work fine. Let's go ahead and bump this from scroll speed of 1 to scroll speed of 20. And we'll just... Actually, we'll put it at 25. There we go. And now let me just take a quick look at what's going on with our server here. Because this should not be jerking around like that, and it absolutely is not in the other project. I'm just checking to see what is different here, because I clearly did something differently. That's the only thing that we changed here. Yep, that is correct. It must be client side. Okay, so let's check our client here. What did I mess up? We've got our input. This is ARPG camera. We don't care about this. This works fine. What we care about is in input manager here. So we've got our rate limit there. We tossed in the keybinds for the input manager, but that shouldn't cause any issues here. For the update, this all seems the same. Yeah, this is literally the same. For find mouse position, there is one small change that we did, and that is that I inlined this. So instead of this was out raycast hit, and then we didn't have that call anymore. Let's see here. Anything else here that I changed? No. And then Q command is exactly the same as well. So what did I do? The only thing I can imagine is that maybe I messed up something with the server time in UDP, but I don't think so. Let's check here. Server time.toString, server time.toString, and server time.toString. Okay. Well, let's just fire this up again and see if I can isolate this down. If not, I may have to put in a cut and see if I can figure it out off camera. I'm not sure what the difference is here, because in the other project, it was exactly smooth. Or almost exactly. There's just that tiny juddering when you're changing directions, because it comes at it from a slightly different direction. But that was not really a thing that was happening. Okay. Kind of a latency are we showing? I mean, that's a little high. But I also don't trust the client latency calculation. Like, at all. Also, let's just... Yeah, that's all working. Ooh, that's sensitive. That zoom is way too sensitive. Okay, that's fine. So it's when we issue the command, for sure. There's that known issue about the rotation. That's definitely a little strange. Okay. Well. Maybe it's just because we're on a zero latency system right now, and it kind of isn't expecting zero latency. That might have something to do with some of the weirdness. Yeah, these turns in particular, I think we need to check on the server the actual tick calculation here. mathf.floor latency divided by game speed. Realistically, when our latency is this low, it shouldn't be doing any compensation at all. Yeah, it shouldn't be doing any at all, because our latency is like 3 to 8, according to the server calculation, which is the one I trust more. It's 3 to 8 milliseconds, and that should be returning a mathf.floor, so this should be ticks of 0, and I equals 0, I is less than ticks, I++. This should instantly output, or instantly break out of the for loop and not do anything when our latency is this low. It could just be that it is expecting some level of latency, or it could be that we need to change our game speed. Like, we could try changing our game speed to, say 16.667 milliseconds. So, actually, we just have to do, like, 16. That would be essentially 60 FPS. It'd be higher than that because we can't do decimals, but we'll try this and see how that feels at a higher tick speed. If it's the low latency, then this should solve it, or at least come close to solving it. Well, are we going to get an encryption handshake? I mean, I don't expect that this is going to solve anything. This is just going to give us additional information, right? So, there we... Whoa! Yeah, that's going to be a thing. That is certainly going to be a thing. We do not have this normalized on the server. We need to do that. So, we need to set this equal to, let's see here, when we're in the entity. We need to set our delta time, and that's because our delta time is currently being hard-coded. That's right. Our delta time here is... Yeah, that's a constant. 0.1f. So... that would cause that issue. But that said... I mean, I think we just change this back, because we do want this to actually be 100. We don't want to be sending 60 per second. That's just overkill, I think. I'm pretty sure that what we're seeing here is one too many game ticks. Actually, you know what we should do? We should go into the instance here, and if I'm correct, then we should say if ticks is not equal to 0, then we run this for loop. Otherwise, there's no point in even entering it. Because I think I was seeing one more tick than usual, or than expected. Because I think it was running that first instance of the tick regardless of our latency. Maybe not. I mean, there's some degree of jittery that we're never going to get rid of with a client-server implementation like this, right? Where we're doing authoritative server movement. There's some degree that we're not going to be able to compensate for that. And we might be running into that diminishing return here, but that was without any latency compensation because of our... had to wait for the encryption handshake. I'm a moron. But that was without any sort of latency or encryption. What am I... Words are really hard for me right now. What we just saw was without any sort of latency compensation or time travel here. And, yeah, we need to wait for this to finish. And what we're about to see is with some level of latency compensation, and it does seem to be smoothed out. Because essentially all we're doing here is we're going into the past, changing that entity in the past. You know what we're not doing? We're not calculating where that entity is supposed to be in the past. That's why it's not working quite as expected. So, how do we calculate where the entity was supposed to be in the past? Because that's clearly what we're missing here. Calculate where entity was in the past. That many ticks ago. And this would get slightly worse. Yeah, this would get worse the higher ping we had. This is what we need to know, though, because we need to then set entity.position equal to a rig position that many ticks ago. And then we on-tick. Yep, that's what needs to happen. However, I don't have a plan for how we're going to calculate that. I mean, this is pretty much... We're going to have to keep track of all of the commands, at least up to X time ago. With X time being like our maximum latency tolerance. Okay. I think, yeah, we know pretty much what we've got to do here. So let's hop over into our client real quick. And in the to-do here, we are just going to say that we have now done input rate limiting and mostly latency compensation. But our next episode is, in fact, going to be... what do I want to call this? Deterministic game states and backtracking. Yeah, we'll call it like that. So that'll be next episode when we figure out how exactly we are going to determine our previous position and set our position to the position at this time. So that is how we're going to do that. Yes. Yes, indeed. That's the issue. And with that, I'm going to go ahead and put a cut in here, and we're fixing that one next time. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I'll see you all when we fix this particular issue next time.